All right. Hello, everyone. My name is Brandon Tremelling. I am going to be moderating today's webinar. I want to start off by thanking everybody for making time to attend this session and to learn a bit about new advancements and some case studies relating to sanitary sewer rehab. While we take some time for additional attendees to kind of filter in, I just wanted to go over a few things kind of relating to what led to today's webinar. Um, to summarize, we had a recent project that we were honored to be involved with in the city of Surprise, Arizona, where we felt that this project would make an excellent case study for marketing to our industry and informing engineers, contractors, and agencies alike about new advancements in terms of permanent corrosion protection for rehabilitating existing sanitary sewer infrastructure. So with that, I want to move into our agenda. We'll start off by talking a little bit about this PVC manhole system. We're going to watch a short video that will hopefully lay a foundation for us to build our discussion upon. We have a number of panelists here that we will then be bringing in to discuss the history and decision-making process about selecting this particular product for the rehabilitation of some manholes in the city of Surprise, Arizona. We'll talk about these materials specifically, this product specifically, and the development of it. We have a representative from the contractor who can speak to the installation process, and we will try to focus this towards lessons learned and future impacts and applications so that any of you who are dealing with current concerns regarding your sanitary sewer collection systems or any design work you're doing, hopefully this information will be made relevant to you. So with that, I want to now introduce our panelists, and we'll bring them on screen now for you to see their bright and shining faces. And I will ask them to unmute themselves and go ahead and introduce themselves and kind of their role and the perspective that they're bringing to our panel discussion today, touching on how your background makes you kind of suitable for discussion on this topic. And if we could, we'll just go down the list here. So Chris, would you mind leading us off?
Sure. Thanks for having me on the panel today, Brandon. So my name's Chris McDonald. I'm the president of CPM Pipelines based in Phoenix, Arizona. We were the first company to really introduce this system to the market several years ago and have probably installed close to 500 of these systems with different contractors and agencies across the Southwest and Texas over the last few years. So we've had a lot of experience, learned a lot of lessons along the way, and looking forward to talking to you more about it.
Levi.
Yep, I'm Levi Hawkins, project manager at CPM Pipelines. My background's in a lot of pipeline and structure condition assessment and rehab. So I was involved in this project really from the development stage all the way through to the execution, including being out there on site. So.
Awesome, thank you. And Jake?
Thank you, Brandon. My name is Jake McLean. I'm with Hughes. My primary role is a regional sales rep, but today my relevance here is I'm the product manager for Hughes Lock structural point repairs. You'll see how that ties in here in a bit.
Yeah, excellent. Again, thank you all for being here. And with that, I think we'll move on to our video highlighting this project.
So we're out here in the city of Surprise rehabilitating 2 gravity sewer manholes. These manholes specifically were chosen because there's a 24-inch force main that discharges just upstream of the first manhole. So as you may know, with force mains, there's a lot of flow and a lot of caustic gases that get introduced into the gravity system. So with these manholes being so near to the discharge point from the force main, they're undergoing significant corrosion and degradation from the H2S gas. So the City of Surprise, our client, had some options for methods of rehabilitating these manholes. A popular choice is epoxy coating, but with manholes that are seeing this high level of degradation, an epoxy coating can last as short as 2-3 years, maybe 5 at the most, and then you're back out here epoxy coating it again. The Geneva method for manhole rehab with the fiberglass bench and the PVC riser is a lot different than epoxy coating because it's a structural rehabilitation and it's made to last 10 to 20 times longer than an epoxy coating. When it comes to installation for this type of rehab, in my experience with epoxy coating, the sequence of events is you're pressure washing, you're putting in new grout for the epoxy to bond to, and it can take 2 to 3 days to do that. We were out here starting on Monday doing our 2 manholes, starting from excavation and removing the cone, and we're here on Wednesday and we're just wrapping up our second one. So as far as a time frame, it's on par with other rehab methods, if not a little bit faster with how fast the pieces stack up. I've done a few projects with this method, and I think really from start to finish, it's very straightforward. Putting the bench in and then stacking the components on top. It's really hard to make mistakes or get hung up on any real tricky parts of the installation. We're really lucky this time to have a couple representatives from Geneva out here to kind of point us in the right direction on stuff and take notes, and frankly their willingness to take what they learned and our feedback here in the field to improve the next one is great for contractors and engineers like us.
All right, so now we want to dive into the history and decision-making process regarding these manholes specifically and what went into the decision to rehabilitate instead of replace. And again, we invite all of our panelists to contribute as you see fit to participate. So the first question I have for our panel is, can you provide a brief history of these corroded manholes and why they specifically needed rehabilitation, maybe in terms of placement in the collection system?
You want to talk, Levi, or am I up? I'm assuming I'm taking this one, right?
Yeah, go ahead, please.
All
I'm
right.
still cringing from watching myself in the video, so.
So we've been working with Surprise for some time, and we've been talking about these specific manholes for quite some time as well. We had actually performed a rehab from the bench up on a previous manhole about 1.5 years, 2 years ago. So the main factor that they were considering when it came to choosing between replacement and then trying to do a full rehab from the invert up with a 50-year warranted, corrosion resistant, 100-year design life type system was you've got so many more factors. If you try to start pulling manholes and replacing manholes, you almost inevitably have to set up a bypass system. So from the minute we started developing this system, like I said, it's probably been almost 5 or 6 years ago. Our goal was always to try to figure out how to do this as quickly as possible and avoid setting up a bypass. So what we were finally able to do using the Q's lock couplings, which we'll probably talk more about later, was come up with a way that we could get those Q's lock couplings in and get that bench in place really quickly. So we didn't have to put the system on bypass. So that probably saved a day on the front end, a day on the back end or more, plus some significant cost. So once you factor that into it, this is basically building a brand new structural manhole inside of the existing structure. So the excavation's much less. There's no bypass. We figured out a way to do these quickly, like typically within a day with no bypass. So I think that was probably the main consideration. And then, as Levi's mentioned, he's had a lot of experience with epoxy systems. And there's some great companies out there that do a great job of putting epoxy systems in, but it all comes down to the prep work. So you're really leaving a lot of things to chance and having to be validated and verified and QA QC'd in the field. So what's great about this system, everything's built in the factory. So you get a factory built, factory designed system that's fully structural, quickly installed, no bypass, cost savings. We're looking at some other structures up north that we're looking to do our first one out of about 10. And we actually compared that side to side with replacement that included bypass, and we were significantly less expensive, probably 25 to 30% less expensive than what it was going to cost to bypass. And this specific project in Surprise would have been much the same.
Awesome. So yeah, absolutely. Bypass pumping can, immediately cause, the cost of any project to tremendously increase. So how much value would you say the city determined the speed of installation or rate of installation and the lack of a need to bypass in terms of value against any other options considered?
I'll let Levi take that one since he was out there on the site most of the project.
Yeah, I mean, from a time perspective, if I'm understanding the question right, like I said in the video, I mean, when you're doing a coating, you've got to wash away anything that the epoxy is not going to bond to, or really your grout that you're putting back on there. So that can be a day, right? Just in itself, just washing them, and then you've got to come back and grout it to make sure there's a good surface for the epoxy or whatever coating to bond to, and that's got to cure, right? So that's another day for that, and then you're coming back and coating it. Now, obviously, you're doing this on more than one per day, but all the value that there is in this system, I mean, I can't understate how doing it in a day and a half each at the end is, it just doesn't compare.
Gotcha. Now, were there any hurdles in that decision-making process? When working with the city and proposing, various options, were there any concerns or anything of that nature?
Chris, I mean, I can't necessarily speak to that. I know they were familiar with the system, so it was something that they had seen. But I'll let Chris chime in.
Yeah, this is in a part of town that's fast growing, and the road that it's on now isn't a major road, but it probably will be in the next 4 or 5 years. I don't know what the schedule is as far as widening that road and building that road out to deal with the growth in the area, but they don't want to have to go back. These manholes weren't that old. They've got a major line going down this roadway, which is 24-inch diameter, coming from the force mains that discharge into it. So, they just didn't want to have to go back to this manhole again. So I think that was the biggest benefit for the city. They wanted to spend the money because it's a little bit more expensive. If you start looking at if you take the bypass out of the equation and just look at the two systems in and of themselves, you might save 10, 15, 20% on just simply doing an epoxy system of some type. But over the course of 10 years, you far exceed the cost of this system because you have to go back and do it again. You have to set the bypass up again. You have to do the epoxies. You might not be able to fully rehab the bench with an epoxy system. Typically, they'll just go down to like the flow line. So,
Yep.
I think those were some of the things that we're thinking about. Just long term, we don't want to be back in these structures again. This is probably going to be one of the last chances we have to do something permanent to repair them. And this is the most permanent system that can be effectively put in as quickly as we did, which it took about a day and a half. I think the next time, if we have the same contractor out doing this project again, because keep in mind, this was the first time this contractor had put this system in, and for them to get this done in a day and a half was really remarkable. I think the next time, given the exact same circumstances, situation, size, everything else, they get these done in a day probably.
Excellent.
Yeah.
It looks like we're getting questions coming in, and I'll just say that we will have a Q&A session at the end. And just to reiterate, we are recording today's session. So any questions that are submitted, feel free to send those in. We will address those at the end. And then this video will be made available for anybody who has already registered, and then will be posted for anyone else who was not able to make it today that would like to use this video as a resource learning about this product and this case study in particular. Going back to the questions though, I'm just wondering in terms of your experience, Chris and Levi, having installed many of these systems over the years, how did this manhole stack up in terms of the level of corrosion that you saw here? What at what level do you typically suggest looking at that permanent rehab option versus maybe more short-term solutions?
Honestly, for me, these were some of the worst that I've seen. I mean, even looking at the pictures you've got on the screen right now, like this is what it looked like when you open the lid. Going back to some other rehab methods that involve, cleaning with high pressure water. I mean, I've seen manholes that look better than this, frankly, that you start washing it and all of a sudden you're getting dirt inside the hole. Like that concrete's just rotted all the way through. So, and the gases, and it really goes back to that decision-making process because, some of the more, I guess, short-term solutions for these, when you've got this level of gases, and I mean, I was standing above it. We had 2 blowers in there and our air monitors were still going off every 30 minutes. We had to pull guys out. So when you've got this kind of environment, it's just, it was the right solution for it, for sure.
Absolutely. And we'll kind of get into speaking about the materials that are involved with this product and its design considerations. But Chris, I believe you said earlier that at this point, this manhole it got to the point where you were considering that there was a last chance, to prevent this manhole from being replaced versus rehabilitated, likely due to the level of corrosion that was being seen here. Am I right?
Yeah, 100%. And Levi makes a good point. I lost my train of thought as I was as I was listening to finish up what you were saying. But a lot of times when you inspect a manhole, a level 2 manhole inspection doesn't require somebody to actually get into the manhole and start poking around with like a screwdriver to figure out really how bad it is. It's just a visual inspection or a scan. So, I mean, I'm curious. Levi has a lot more experience with manholes and doing inspections and then going out after an inspection was completed, maybe a scope of work was put together, then what they get into once they're on site, thinking they're going to repair it, maybe with epoxy or just with the skim coat of, grout over the top to prep it. Like what kind of problems does that cause, Levi, once they're out there ready to execute a scope?
That's perfect. And that's something I've been saying, I mean, for years, honestly, and not to knock, the assessment process for manholes, but you're exactly right that, doing a level 2 inspection and noting that maybe there's some mortar missing or, there's a crack or the ladder's corroded, whatever it may be. And you slot that to be rehabbed with an epoxy coating because you don't think it's that bad. And then day one, they go and pressure wash it. Just like I said, now you're washing away structure. You've got other concerns. You really don't know what the right solution is sometimes until you get in there and get your hands on it and see what's left and what's structural.
Excellent.
Yeah, so I think our system, with this system, you avoid those issues because we're assuming it's fully degraded.
Mm-hmm.
When we decide to put this in, it's fully degraded. The thing is going to be fully structural. If it's just as bad as the surface looks, or if you stick a screwdriver and you put a screwdriver all the way through the entire wall and you hit dirt, our system's going to work. We're not going to have to change the plan. We're still going to get it completed in a day.
Absolutely. And that's a perfect segue to kind of speaking towards the materials and the design of this system, because I'm sure most of our attendees here just, said, wait a second, you're poking straight through the wall of the manhole, you're hitting dirt, and you can still rehabilitate it, because that sounds pretty questionable. But my role here, in addition to being moderator of this panel discussion, I am representing kind of the manufacturer side of things as well. So I'm going to spend some time speaking about the materials that are used in this system and why they were selected in addition to the design. Again, rest of the panel, please feel free to jump in. We're going to have some specific questions for Jake here in a second. But I wanted to speak to the materials that are used and their specific corrosion resistance. So as you can see, in this photo that's shown right here, there are a couple of materials highlighted. We've got that lined flat lid, which is in this case study was lined with a fiberglass reinforced polymer. The riser section of the manhole was lined with large diameter PVC pipe. And these materials have been extensively tested for their corrosion resistance. There are various tests throughout our industry that can be recognized for determining the properties of materials when exposed to various types of corrosive elements. And the one that we as a manufacturer have determined to use just based on its reputation in the industry is what is known as the pickle jar test from the California Green Book, which essentially we take samples of all the materials that are used in the system and we isolate them, subjecting them to exposure for various corrosive elements for a period of time. And what we do is we test its tensile properties, its compressive, its flexural, its overall weight, things of that nature, just trying to get an idea of how these materials hold up to exposure to acids, bases, even detergents. We'll even have a bacteriological, a BOD component to it to determine if there's anything likely in a wastewater collection system that can weaken or compromise the system in any way. And so that is a kind of a snapshot of the testing for specific corrosion resistance that went into this system. Now, above and beyond that, what Chris was just speaking to, if you have a structural concern with a manhole that you're trying to rehabilitate, there's always the concern of, well, if the existing wall doesn't have much structural capacity left and we're literally hitting dirt or we're seeing exposed reinforcement, how does this system compare? Well, one of the things that is incredible about this system is that the lined or the pipe that was selected for the riser section has been tested and third-party engineered by a couple of different consulting firms at this point to determine that this system is fully capable of withstanding AASHTO loading, regular traffic loading, in and of itself, making the strength and structural capacity of the existing structure irrelevant. So what we're doing here is we are essentially building a manhole within a manhole so that the level of corrosion or degradation that we have previously seen due to corrosion no longer is relevant in any way, because that inner manhole, this hybrid PVC manhole, now is taking all that loading and is capable of providing that strength and structure in and of itself. Now, a few of the unique design features, maybe Levi, I'm not sure if you were involved in this process, but can you speak at all to how this system was specifically modified for these manholes in the field?
Yeah. So, like I think I answered one of the questions in the chat. We actually had a 3D scan that's sometimes used for condition assessment, but in this case, we used it really just to recreate a point cloud of the manhole, such that all of the intricacies and nuances of the bench and the channel, and not just when it was designed and installed, right? All the things that have happened to it over time that change its shape or change the diameter of the incoming and outgoing pipes. That's all accounted for. So that one piece bench liner that you probably saw in the photos or in the videos, those aren't just off the shelf based on the pipe diameter. That's a completely customized piece that literally drops right in and fits. Now, I've had times where you have to make a couple little adjustments to it, shave a quarter inch off one side in the field, but really it's a snug fit. It drops right in, and then the riser, like you said, that's just a piece of PVC pipe, and then the flat top fits right inside it on the top. So
Absolutely. So I like this photo right here to just show how snug that fit is based on that 3D point cloud, because the idea is, once that base liner is created, it should be a near exact fit to fit in there. And then we'll kind of get into the installation practices of what we do with that annular space and things like that. But once we have this liner in place, we sleeve the rest of the manhole with a large diameter pipe, put a lined flatlet on top is kind of the gist of it. One question that I think most people have pressing, especially in this photo where clearly there were live flows going, there was an active pump station going on for most of the construction or rehabilitation, is what do you do about that seam between that base liner and the pipe, about protecting that joint there for additional corrosion, even if you grout it in, what prevents the corrosive elements and gases from eating away behind that liner? Jake, this is where I'm going to ask you to jump on. Just as a reminder, you're currently muted. But I just wanted to ask you or our other panelists, if you want to answer this question, how were these inert materials joined to the pipe? And can you kind of speak to that process?
So the sleeve itself is constructed out of 316 stainless. That's been proven to have a 100-year service life in these corrosive conditions. And then the material on the back side of that is a polyurethane grout. Water activated, expands 12 to 1. That helps to seal off any gaps there and also bind that metal sleeve to the host pipe.
Okay, awesome. How was that installed?
In this case, it was installed with just a regular plug. If you were installing it in the middle of a line, you'd have a wheeled flow-through packer. You just need something that'll blow that thing up to the specified diameter. So in this, like I said, in this case, when it's right outside the manhole, you don't need anything fancy. Just the correct diameter plug is all you need.
Okay, and in that previous photo we saw there, they were saturating the outside with a type of resin. I think you mentioned that briefly. Can you kind of speak to what that does in terms of any sort of corrosion protection or adhesion, or what is that really doing in this connector?
Yeah, so a little bit of both. So what that does is, like I said, that's a single part polyurethane grout. So when exposed to water, it expands 12 to 1. So the primary function of these sleeves is structural. Fixing crossbores, separated joints, connecting pieces in this case. But that will expand through any voids, cracks, gaps to help seal off against that infiltration and also to kind of limit where those corrosive gases can travel. So that provides a barrier there. And then also, just in layman's terms, the great stuff foaming door and window sealer at Home Depot. This stuff chemically is very, very similar. So if you've seen how that works, it expands, it gets very rigid. While it's curing, it's extremely sticky. So that provides a very nice bond to the host pipe.
Okay, so we're providing kind of a structural connection between the pipe and the liner to provide that protection against those corrosive elements. I guess, can you speak at all to any sort of testing for corrosion resistance that's been done on these materials or on the system as a whole?
On the system as a whole, specifically, I have a document here where it was tested to a 100-year service life. Oh. And that was done by Arthur H. Tuthill, PE, out of Blacksburg, Virginia. So this study is a pretty detailed study covering the long-term corrosion behavior of 304 and 316 stainless steel specific to the repair of municipal sewer lines. So it does have a lot of documentation backing it up and how that was done. And like I said, most of your corrosion resistance, the study is specific to the grade of stainless steel used.
Gotcha. Makes sense. Can I ask what sort of sizes the Q's lock system comes in?
6 inch diameter, 12-inch length on the small end, 48-inch diameter, 36-inch length on the big end, as far as installed with the packers or plugs. Anything above 48-inch diameter comes in multiple pieces, and you would actually walk that into the line and install those by hand. You'd have 2 pieces at the bottom that stack in, and then the piece at the top is a hinged plate that expands to provide that last piece of the puzzle.
Gotcha. So regardless of kind of the pipe sizes that are going on, as long as it's not smaller than that 6-inch size, it's a suitable system for, joining these corrosion resistant materials together to prevent any further corrosion from taking place. Is that correct? Awesome. Okay. Has there been any sort of testing done on this system for its infiltration resistance?
Not that I know of. Again, primary function is the structural. It does help with infiltration based on that grout, but I don't know that that's a hard one to quantify because you're applying to the grout to the outside of the sleeve. You're dragging it in place in many cases down a sewer line. Depending on how that goes, you could be rubbing some of that material off. If you're using it for an example of lining, you're going to install a liner. You're going to use this. In the meantime, you got a gusher coming in. That's going to slow down that water enough that then they can dewater and shoot their liner through it. In that process, some of that grout is going to get washed off by that gusher. So in that case, it's just a Band-Aid. So there's no real way to say, okay, in every situation, it's going to behave like this because there are so many variables with the install and the application of how it's used.
That's a good point. And in this application where likely most of the time where you've got this liner and there's possibly live flows going down and there is any infiltration, it can leak directly into the channel, continue on, and then during the installation of that connector, once that's in place, we'll speak to this in a minute of filling that annular space. That connector then should be surrounded not only by the pipe material, but then will be locked in place by the additional grout and further installation procedures, which we'll talk about in a moment. Now, kind of getting into the structural or durability aspect of some of these materials, I just wanted to take a moment and speak to some of the testing that has been done on this FRP liner. So my company, again, speaking as the manufacturer's representative, when we were looking at bringing on this product that we could then bring to market through CPM and some of our other partners, we wanted to look at testing that had been done on these materials for aspects such as abrasion resistance and their ability to provide that corrosion resistance long term. We've spoken a little bit about this idea of permanence in rehabilitation methods, and I just wanted to take a moment and recap one study that was done in which there was a manhole base that was taken out of service that had been previously lined with this material with a liner much like the one you see in this photo. Had been taken out of service after 20 years in a standard sanitary sewer collection system. There were then cores taken of the manhole base straight through that liner, and those cores were sent to a third-party testing agency to determine the level of health or conversely degradation that had occurred on the backside of that liner after 20 years of service. And essentially what was found was that after those decades of service, there was essentially no variation between the strength and health of that concrete on the day those cores were taken versus the day it was first installed. So that is what has led to this idea and discussion of permanence. And when we're talking about, we've got a manhole that, is very significantly corroded and requires rehabilitation that is going to withstand its 100-year lifespan, that is where some of that information is coming from, the data that's been collected in those methods. So there's a very high degree of confidence in this message that these materials are going to withstand even the harshest conditions. I mean, Levi, you said that in your experience, this was one of the worst manholes. And I had the luck of and good fortune of being on site to witness this installation. And I actually told Levi yesterday that I took a video of one of the contractors' guys down in the hole just using his hand to brush concrete off, and it was pretty incredible, just the level of degradation that you can see in a just in a few short years in some of the harshest environments. I spoke again about the structural considerations of this method. Now, as you can see here, and as Levi mentioned earlier in his video, actually, on that first day, there was some excavation that was done and the cone was removed. As you can see in this photo here, there's no cone replacement. And while there is some loss in terms of the height of the manhole, when you remove the cone, that is made up with this riser that then protrudes from the next section that remains in place. Now, what I mentioned earlier about us having gone through the method with various consulting engineers and agencies to do the loading calculations and determine that this PVC manhole system is capable of withstanding the AASHTO loading, the traffic loading, without any additional reinforcement around it once it has been properly backfilled and compacted. So even though there is no cone, there's no concrete riser around that remaining portion of the PVC pipe, it is then, once backfilled and compacted, going to be able to withstand any standard traffic loading in and of itself. So a pretty incredible system there. I don't know if Chris, Levi, Jake, if any of you have anything else to say kind of about these product materials, their design or corrosion resistance or anything else like that.
Yeah, so a couple things worth noting. The impact resistance of the fiberglass is very, very high, because we get those questions sometimes, like, what if I put a jetter nozzle, or if we drop a jetter nozzle or something onto it? So the impact resistance of the material is really significant and really high. And then once you fill it with grout, which we haven't really talked about much yet, but once it gets locked into place and you fill underneath of it with grout, so everything back behind it, because you can see that bench stands up pretty high. So once you put solid grout in underneath it, it's very, very, I'm not sure how to best describe it, but you could probably hit it with a sledgehammer and you're not going to dent or impact or put a hole in this stuff. And when we have to make, if you saw the one picture that had all the tabs on the bottom of it and then down the sides of it, sometimes those have to be just taken off. Most of the time we don't have them on the bottom so that that'll fit all the way down flush into the invert. But to get those tabs off even, which aren't nearly as thick as what the lining material itself is, you have to use a diamond blade saw. The first couple of times we went out and tried to do these projects and make modifications, we were using just typical grinder cutoff blades, and we were burning through, you couldn't even get through 2 inches and you'd burn a blade up. So this stuff is very, very abrasion resistant, it's very impact resistant, and it's very durable. So that's one thing worth noting. We also did a really big project down in southern Arizona a few years ago. One of the first real big projects we did, that I think we had 30 or 40 manholes that we did. And those actually had double cone sections. So we didn't just have one cone, then it branched out and had a second cone. So we actually had to remove 2 full cone sections. So these were 15 to 20 foot deep manholes with double cones that we had to pull 2 sets of cones off. So we had to dig them out a little bit deeper. But we probably had, in some cases, 10 feet of PVC risers sticking up from the very just bottom barrel section of the original structure. And those were all a lot of those were in a roadway in southern Arizona as well. But same idea. They're, H20 load rated for traffic. So once you backfill it, put slurry back around it, or just compact it and backfill it, these things are just like putting a brand new manhole in. And I think that's worth mentioning as well. We use these same components to build brand new manholes, with basically the only difference being the bench section that we're dropping into the existing structure that just gets poured into a precast base. So, and then it just stacks out from there. So we can build these exactly the same way with just providing a base as we do to rehab.
And those bases look a lot like the flat top, right? For new
Yes.
construction. So
Yeah.
Yep, they do. Absolutely. Now, just because I want to spend plenty of time on the actual installation process, would Levi or Chris or both of you in collaboration, would you speak to what that installation process looks like for this system?
yeah, I mean, I know we probably touched on each piece maybe individually, but just starting from the beginning, you know, in this specific project, we probably excavated maybe a 6 foot by 6 foot trench down to the joint where the cone sits on top of the barrel section of the manhole. Pull the cone off, it's done, go into the junkyard. And then it's a matter of dropping that bench piece in, getting that lined up, putting the Q's lock couplings, which lock it. And what they also do is prevent, because we'll pour the grout behind the bench liner. So those Q's lock couplings also prevent grout from seeping into the system and getting washed downstream and, you know, making a bunch of problems. We'll let that bench grout set up a little bit before we start dropping anything more heavy on it. But within the same day, we put some mastic around to water seal that interface between the bench and the riser. Drop the riser piece down, mastic around the top of that, and then the one piece flat top. And from there, it's just a matter of using the right grade rings to get it to the grade that they want. In this case, they wanted it a little bit higher than the original manholes were for some flooding issues that they were seeing in the area. But I mean, if it sounds simple, it's because it is. It's essentially 3 pieces that you're stacking up.
Gotcha.
And I think the other thing to mention in that same vein, you don't have to have any specialty equipment. There's no special training required as far as like learning how to use spray equipment, learning how to properly mix grout and different components that you have to try to get to stick on the walls. So there's really any typical civil contractor that you've got out there that you trust and you work with, they can put this in basically just about as easily as they can install a new manhole for you. So it gives you a lot of different options as far as getting these put in the ground. And it gives you a long-term, you know, solution at the end of the day with, like we've said before, little to no QA QC required in the field. Once they stack them, they put them in, you don't have to go back, you don't spark test this stuff, you don't do pull tests on this stuff. It's just, you get it from the factory exactly the way it goes in the ground. It gets dropped in the ground piece by piece, and it's going to be exactly the same every single time, 100%.
And just to add on to that, Chris had mentioned before that our civil contractor, you know, this was a first for them. But even internally with CPM, I mean, I was really the only one out there that had even really seen this be done before, let alone install one. And, you know, it's all our guys picked it up. If I sent a crew out that was in surprise to go do another one without me or without anybody that's seen it before, I have 100% faith.
Awesome. Yeah, thank you for that recap. Absolutely. I want just a few more questions, and it looks like we've got quite a few of questions in the chat and the Q&A both. So we'll try to save some time there at the end to go over all of those questions. Can you talk about any sort of any management, you know, processes that were in place to make sure that this project stayed on track? I guess, what was the expected timeline for start to finish, and how did that match up to the final tally?
Yeah, so we I think we had a week total set aside for it, and I think really by Monday we knew we were gonna crush that. I mean, we were pouring concrete collars Thursday morning, which actually got added to the scope. So essentially we did it in 3 days. when planning for 5. As far as management, I mean, I'm sure there's some people in here with experience with this. You know, anytime you've got material coming from, you know, out of state, you've got a contractor that you're kind of working on something with for the first time as far as the project or the type of work that you're doing. And, you know, we had material getting stored at a yard a couple miles away, just all the typical time management, making sure, you know, people are aware of what the next steps are and making sure the contractor understands what they're doing and really just being there, I think personally, and not being there in the truck trying to work on other projects that I have to do. But being there, getting my hands dirty, making sure I'm there to answer questions or keep things moving. But you know, all the material came in one delivery, so we knew we had everything that we needed. Had a good contractor. Really just blew this one away, in my opinion.
Yeah, and kind of speaking to what you've mentioned, and Chris, you mentioned as well, just the simplicity of, there's not really specialized training that goes into this. There's only a few joints total that need to be sealed and just sealed with mastic. It's pretty simple. In fact, where we're based out of Utah as the manufacturer, of course, we provide the solution nationwide, but here locally, there have been a couple of agencies that I work with pretty frequently that have taken interest in doing this installation and this process in-house, because once they have determined the simplicity of the installation, it is given them great confidence in the solution, in addition to the performance, the loading, the corrosion resistance, and so pretty incredible system overall.
Oh,
Can you go ahead?
I was just gonna say, I mean, one way to think about it really is that, you know, the riser sections on these, and I might be foggy on it, but I think they were like 18, 19 feet tall. And, you know, you think about doing this with a concrete structure where you'd probably have, you know, 3 or 4 joints trying to stack something up that high. You know, the riser being PVC, being light, being one piece. I mean, we basically accomplished, you know, 18 feet of progress in 5 minutes. So just incredible.
Yeah. Yeah, very
And from a
fast.
safety aspect as well.
Yep.
When you're looking at this from a safety aspect, whether it's new construction or rehab like we have in this case, yeah, if you were trying to stack multiple barrel sections, you'd have to have a person down there setting the mastic and making sure it's lined up. And there's a lot of potential safety issues, where with this system, you just go down, put the mastic in, pick the riser up. You don't have to have anybody in the hole. Drop it, set it in place. It lines up perfectly with the outer edge of the bench that we custom make. So it's a perfect fit. And I think one of the questions, Levi, were these 60s? These were 60s, right? We dropped 54s in.
Yep, exactly.
Yeah, so these specific ones were 60-inch diameter originally. So 5 foot, we put 54-inch, and 54-inch C900 pipe is, I think, 58-inch OD. So we only had about an inch of annular space around the outside that gets filled with slurry or grout when we're finished.
Yeah, I guess we didn't really talk too much about that, but yeah, I mean, part of that setting the riser in, there's not really any potential for error on that, but you do want to make sure you've got some kind of gap between the old riser and the existing one, so that grout has got somewhere to go. But the more corroded the existing manhole is, the more space you're going to have just by nature of what's concrete is remaining.
Yeah. All right, I want to pause there. I do have more questions, but we have so many questions from our viewers in the chat that I want to make sure that we can jump on that. It looks like there have been some questions already answered, talking about the removal of rungs in the existing manhole. Yes, whenever there's ladder steps, those do need to be removed. However, they could be reinstalled if necessary. As a manufacturer and kind of as a technical resource engineer is actually my title for our industry. I've noticed many agencies kind of moving away from ladder steps. And so a lot of agencies determine that it is unnecessary to add those ladder steps back, though it is possible to do.
And those can be factory installed too.
Yes, absolutely they can. Let's see. Is this a manhole project or have you lined the sewer with it as well? This product is specific to manhole rehab, and in smaller diameters, typically we're looking at 60-inch manholes, 48-inch manholes that can be relined with a slightly reduced ID. So if you have a 48-inch manhole, we can line that with a 42-inch pipe. So you're losing a few inches of that internal diameter, but you are adding inches back of structure when you account for the additional grout in that annular space. So realistically, that structure will be stronger than it was the day it was first installed after the rehabilitation with this method. And panel, feel free to answer as well. Let's see. The inside diameter, I guess I just spoke to that. The inside diameter,
Cost comparison.
yeah. Can you do you want to speak to that, Chris, at all? Do you have any?
Yeah, sure. So the cost comparison, again, if you're just looking at somebody coming back, not doing much heavy cleaning, skim coating it, and then putting an epoxy system back over the top, it just depends on what you're trying to accomplish, right? Like, what's the goal? Is the goal to get a system in that maybe has a 10-year warranty? One of the clients in Southern Arizona, they bumped their epoxy requirements up to a minimum 10-year warranty. So that probably more than doubled the price of what they were paying because they weren't having manholes last 4, 5, 6 years. They were having to be back out there paying for all this expense again. So long term, we've done calculations with different systems. We've done with like lift stations and different things, and we've shown that it's less than half or a third of the price long term if you're looking at a 50 to 100-year design life. So it just depends on how you want to invest your money. You know, do you want to invest it once, or do you want to invest it every 5 to 10 years and deal with the potential headaches and consequences that come with that? So if you're willing to kind of step up, do it right the first time, make sure it's permanent, this is going to be much, much less expensive over the life cycle cost of the system.
Absolutely. Thank you for saying that, Chris. And I also want to point out that with this manhole being as corroded as it was, it's likely that the city realized that they either had to rehab this manhole or these manholes with something that would be permanent or risk a somewhat catastrophic failure. They couldn't risk, using a liner that may have a shorter design life. And I don't know that it's been said, but maybe Chris, you said it earlier, but this system comes with a 50-year warranty against corrosion. So all these materials are warranted against the corrosive environment that did this to a precast concrete manhole. And so the option to be able to recognize a highly corrosive environment and rehabilitate it once and then never touch it again is invaluable to many agencies that we work with. I just going down the line, we will be sending out a copy of this video, and we do have contacts for all of us listed kind of on one of our last slides. I just answered that warranty. And would you be able to use the same hybrid rehab system for a stormwater drainage manhole structure with a potential lower cost since some of the rehab work items may not be required? Possibly, we'd have to look at that. Feel free to reach out to us about that. We may not require some of the liners for the base and the lid, but that would be kind of a specialty situation that we could look at and absolutely provide some information on. I'm going to move over to our Q&A questions now. Going back to the beginning, what type of loading limits does this have from tractor trailers, heavy pavement loads? Does the old structure carry those loads, or does the new one? I hope that I've answered this already. This was a while ago, so probably before I talked about that. But HL93, LRFD loading, it has been tested for, and we can certify that as well. Next one, how is the base channel liner seal between it and the pipe created? Jake, I think, answered that question with the Q's-Log system about some of that expansive resin and the 316 stainless steel that provides that corrosion resistance. Oh, and you just posted a response, so thank you, Jake, for doing that. Um, David asked, as the sewer flow is less than clean, how does the sewage impact the seals bond between the pipe and liner? Jake, do you want to answer that one at all? About using the Q, and you're muted, but the Q's-Lock system in a live flow situation?
Yeah, very little. I mean, typically when we're installing Q's-Lock, you're going to clean the pipe as best you can beforehand. But that grout is nasty sticky. The first install I ever did, I got it on my hands, thought it'd be a good idea to rub some dirt on it to get it off. And 3 weeks later, I'm still picking it off my fingernails in the shower every night.
Yeah.
So yeah, you want to get the pipe as clean as you can. Short of debris, debris is a problem, but just some dirty water is not. You'll get a perfectly fine adhesion.
And I'll also speak about once that Q's-Lock system is in place that has bridged the gap from pipe to the liner, any residual moisture that is behind the liner itself, when we pour in that high flow, high strength, fast setting grout, concrete cures underwater, right? So that any water and moisture down there is not a problem. And any sort of corrosive elements are going to be a micro film between the existing structure and that new grout that has gone in there, and will be irrelevant as that cures. The process is actually expansive. So anything that does, any little corrosive elements that do affect that bond are literally just expanding and providing additional compression in that bond there. Let me see if there are some new posts. Couple last questions from Tyler. Is this method cost competitive for new installs compared to concrete manhole costs? And how does PVC rehab costs compared to a CIPP liner? Chris or Levi, do you have any thing you want to add there or any feedback?
Yeah, I mean, just like anything you're going to use that's highly corrosion resistant, if you've got typical neighborhood flows that, in 48-inch diameter manholes and they last 30, 40 years when they're made out of concrete, that's probably not the ideal situation to use these types of systems. They certainly can be used there, and they're not that much more expensive when you look at new construction, to be honest with you. But you're going to spend, $4,000, $5,000, $6,000 more probably on the components, maybe a little bit more than that. So, but each project is kind of project specific. So it's got its own specific issues and challenges, and you want to use the right material for the right project. So would we love for you to put these in on every single manhole you put in? Absolutely, but that doesn't make very good financial sense for the most part. And then the CIPP, the biggest issue I've seen with the CIPP inserts where they blow the bags in and expand them out, you've still got a lot of QA/QC involved in that process. The bags, I mean, there's a wet outs performed in the field. I mean, especially here in the Southwest, you got dust and debris and all kinds of stuff floating around and wrinkles, and you're not going to get a full structural solution out of that. It's just ultimately going to be a lining system at the end of the day. So this is just kind of taking it one step further and eliminating all the QA/QC you would have with a CIPP system even.
Awesome. Thank you, Chris. And we're at the end of our time here. As promised, here is the contact information for myself and all of our panelists. So please feel free to reach out to any or all of us with specific questions regarding some of the agency perspectives that Chris and Levi were able to speak to, the installation process that Levi was on site for and kind of helped oversee, any of those connection questions for pipe joints, pipe seals, point repairs, or the process for sealing from a pipe to a liner. And then for the overall questions about the system, feel free to reach out to Levi, Chris, or myself, myself being the manufacturer's representative. And of course, Levi and Chris can supply a lot of that experience and knowledge. And so thank you, everyone. Thank you, panelists, for participating today. Your feedback was invaluable. And thank you, everyone who attended. Again, if you have any questions, please feel free to reach out, and we hope you have a great day. Last thing, in the chat, Mark Turina, who was helping kind of oversee the flow of this, posted a link for a survey. If you would be so kind as to provide some feedback, or if you are interested in obtaining a PDH certificate for your time viewing the webinar today, that link is posted. It's just a Google form, I believe, that you can fill out, and we will be sending out the PDHs in a couple days. So again, thank you, and yeah, have a great day.